Today we have a very, very special guest with us. I've known this guy for quite some time, 4 or 5 years, if I'm not mistaken. It's hard to keep count nowadays. But professor at University of Cambridge and also a consultant at Xbox Studios, specifically Ninja Theory, as a neuroscience consultant. Good old Paul Fletcher. Paul, how are you doing today, man?
Very well, thanks, Cameron. It's great to see you. And yeah, time flies by, and we have known each other 4 or 5 years.
Yeah,
Time speeds up when you get to my age as well.
we're very excited to have Paul here today, and I think neuroscience is a topic that's been blowing up a lot these days. So I think it's going to be a really interesting conversation, and we're really lucky to have him here today and have his take on that.
Thank you very much. Looking forward to it.
So, Paul, I know, like I said, we know each other for quite some time, and time is definitely flying by. But I'm not sure if I asked this beforehand, but how did you get into this line of work? Like, what sparked your interest when it comes to neuroscience, like the brain, the mind? What made you want to get into this line of work?
It's a great question. So I originally studied medicine in London, England, that is. And I'd been quite interested in surgery. But when I was studying, we did a psychiatry attachment, and I started talking to people on the ward and hearing their stories, and just got completely fascinated by psychiatry. So I decided to specialize in that when I qualified as a doctor, and I enjoyed that very much. And I spent a few years just doing full-time clinical work in quite a deprived area of London. But I became very frustrated by how little we knew about the brain, and how little we could also do for our patients. It was often felt like we were just guessing all the time. And I was very fortunate to be offered a research opportunity looking at brain scans and, with a new technique that had just come in around the time. This was in the mid 1990s. And so I seized that opportunity. And from then on, I've divided my time between clinical work, seeing patients with psychiatric illness, and trying to do the research into brain processes that might improve our treatments, improve our understanding.
Yeah, it's funny as you mentioned in regards to how we think we know everything about the mind. I remember one of your videos you was talking about like how the mind is consistently changing. Because I know you was going within the study of psychosis and just how the mind is always changing, is always, I'm not gonna say adapting, but it keeps shifting. We think we know how it operates, but then it changes like that, just out of thin air and stuff.
Yeah,
It's quite
that's
fascinating.
That's a great point. I mean, I think the one very striking thing, particularly about the human brain, is it adapts. It adapts to anything, and it's really made to be adaptable. We can change our synaptic connections. We can even grow um, new nerve cells. It's been discovered relatively recently. When I was a student, we were always taught that you never got new nerve cells, but subsequently that's been disproven. So we are there to adapt to our changing world, and no matter what we do, our brain encodes it and changes its weights and its connections. Um, and the other thing that's very interesting to me, and something that you and I have discussed, I think, is all of us feel like we know what reality is, that we're directly in contact with reality. And so somebody with a, say, psychosis who has a different reality, they often get stigmatized and treated as though they're totally irrational. But the more I've learnt about the brain, the more I've realized that all of us are constructing our own reality, trying to make sense of it, and we're often getting it wrong. We're often filling in the bits that we don't perceive. So not only do we have a very adaptable, flexible brain, but we also have one that's taking a lot of shortcuts.
That's very interesting, and it's cool to start to get a sneak peek into the type of research that you're doing. And I know you also mentioned that you're doing clinical work.
Yeah.
So I guess before we dive maybe a little deeper into that work that you've been doing on psychosis or on the brain, can you tell us about more generally what it looks like to be, a cognitive neuroscientist for a day? What might someone who is thinking about pursuing this field or someone who thinks that they want a career in neuroscience, what kinds of things can they look forward to?
Okay. Well, the first thing to say, and to be honest, is that certainly at my level, there's quite a lot of organizational work. So as scientists, both in the UK and the US and really all over the world, we are often expected to bring in our own funding, and that can come with some frustration. And we're also judged by our scientific output. So papers, lectures, the things we do, the things we produce. Um, so there's an awful lot of thinking about that and trying to improve that. But that's the bad, for me, the bad bits or the frustrating bits. But there are loads of great things. I mean, for me, the most exciting parts of the day tend to be the creative discussions that you have with scientists from lots of different disciplines, planning studies, looking at data, trying to make sense of it. I think if you like puzzles, you'll love neuroscience. It's very multidisciplinary as well. There's no single set of expertise that can solve or understand the brain. So geneticists, biologists, computational scientists, uh, auditory physiologists, psychologists, philosophers, statisticians, they've all got a part to play in this. And one of the things I really love is just looking at what the other disciplines have to offer. Because they can give me insights that my background in psychiatry and neuroscience maybe don't have. So the good bits of being a cognitive neuroscientist are, well, I suppose, just being able to interact with people from so many disciplines and all being focused on the same puzzles, which is ultimately how can this 2 kilogram lump of wobbly stuff inside our skulls, how can that generate rich consciousness, and how can that go wrong?
You touched a good point, which leads into my next discussion. Everything's like that the not the thought, but just being interdisciplinary, like meeting people from like different fields and everything, because that's how you and I met and everything originally. I just sent an email to you and it was just like, hey, like, have you thought about X, Y, and this and that and stuff? Which leads into actually the next question, but it's like two-part question. You work with game developers or, a big hit, Hellblade, both 1 and 2, which they're both are either nominated, not been awarded for numerous of things, which by the way, congratulations
Oh,
on
thank
that.
you.
Um, the first question is like, how did you come across like meeting Xbox, specifically Ninja Theory? Like, how did that came about and stuff?
Okay. Yeah. Well, first, Cameron, to say that it's wonderful getting an email from someone like you who has this real expertise in auditory physiology and audition, and to realize just how much that can contribute to the way I'm thinking about the brain. So that really reinforces my last point. Being open to alternative expertise, different ways of seeing things is really rewarding. But and in some ways, that was how I got uh, approached by Ninja Theory. So I got an email one day, and it was just they were a very small studio, well, relatively small. They weren't at the time part of the Xbox stable. They were independent, and they said we're making a game, and it had been inspired by personal experience. We're making about a game about someone who has psychosis, somebody who has an altered reality, and we really want to be sensitive and honest and truthful in the portrayal. And would you come along to the studio? And I went along really thinking I'll be a consultant. I'll tell them what I know, and they'll do what they want with that. And um, you know, maybe it'll work, maybe it won't. But it became very clear early on that actually I was going to get a lot of out of this because I was going to work with storytellers and um, sound designers and visual effects people and programmers and game design. And actually, that would give me very different perspectives on how I was thinking about the nature of psychosis and the nature of how we understand reality. So it started off as just a single visit to the studio, and it quickly became clear that it was going to be a lot more than that. Funnily enough, when they contacted me, they really didn't think the game was going to be very big at all. They said, well, it might break even, but it's going to be too niche for people to really, buy into it. But of course, as you've observed, it became a lot bigger than they ever thought it would be.
Yeah, because even when I saw the comments when when there was a not reveal trailer, but inside project, explaining the process and everything. There was comments related to things like auditory hallucinations, with the players and everything and stuff. And so that's why I chimed in as far as just asking questions about auditory triggering and things of that nature and stuff. Um, and so that kind of, I mean, leads to another point slash question, which just, you know, like you said, they never thought it was going to be so successful. It was just niche and everything. But it kind of leads to a point where it's just like, how can video games, from just experience alone, how can video games or video games really help when it comes to mental health and everything? Because it's a simulation of some sort, right? Except it's more
Yeah.
interactivity and engagement. But from this project alone, like how do you see this or video games such as this help when it comes to mental health? And I noticed stuff like games for change, things
Mhm.
for our nature too, which Hellblade is a part of that as far as game for
Mm.
change and stuff.
Yeah.
So
Yeah. Well, I think, Cameron, that there are three main ways that games can be really powerful in addressing mental health and mental illness. So, representing experience, um, also as a tool for challenging the mind and understanding how people and how different brains, different people face these challenges. And finally, I think that there are ways in which you can use the gameplay to intervene. So with respect to the first one, I think I'd always undervalued this idea of stories to represent experience, which was very foolish of me, really, because I'd always been very frustrated about how stigmatizing psychosis and lots of other mental illnesses are. People with mental illness can become very isolated and they can become shunned. Um, and when you represent that experience and you do so within a narrative, within a story that can be quite powerful, actually you force people to step into the shoes of of another character. And when you do that, I think something powerful can happen. And I think, particularly in games where you're not just asking them to sit back and listen to the story or watch the story, you're actually asking them to participate in the story. And I think that's really powerful. With respect to the second thing, cognitive neuroscientists, one thing I didn't say in answer to your question, auditory, is that we do spend a lot of time designing tasks to challenge people's memory or their language function or their attention. And the tasks that we design are so boring. They're really nobody wants to do them. But video games, you think about playing a video game, your cognition is being fully challenged and you're totally engaged with it and you're doing it in ways that are enjoyable and immersive. And I think if we can harness that, we could we could run cognitive tests in a much more powerful and interesting way. And then finally, intervention. Most psychotherapies are about learning. They're about repetition and practice, um, building new models of the world, understanding reality in different ways. And games, again, they offer this opportunity because people will apply themselves to games. So I think, if you're teaching, for example, an anxiety management strategy, you can sit someone down in a lab and just get them to do it over and over again. Or you can build it into a game where they're competing against themselves or other people, where they're developing strategies to make themselves better at it. So I think games can do that. There's representation, there's challenge and measurement, and there's intervention.
Something I think that's really interesting that we've touched on a little bit is this really interdisciplinary nature that your work can take on, and the
Mhm.
opportunities that you have had to sort of meet people from other fields, and with this, with Hellblade, work really closely with people from other fields. So I have another two-part question for you, and the first part is whether you have any advice on other people in STEM who might be interested in this opportunity to combine technology, like a video game, for example, with science.
Yeah, yeah. I mean, I think it's a great question, Audrey. My feeling is that it's something that the assumption is often, oh, you just find somebody and you talk to them and then put your heads together and you'll come up with something. But I think you have to come from a starting point that you're very open to what other disciplines can offer. So you need to have the humility to recognize that you're bringing us a piece of expertise, but there are lots of other complementary expertises that can can go with that. So, as a neuroscientist, maybe it sounds strange that I would work with storytellers and scriptwriters and audio design. But if you're humble enough and you realize that you don't have privileged access to the truth, then it puts you in the right mindset that you're going to listen to people and see what they're bringing. And I think also that collaboration has really helped if you have, if you care about the topic. So for me, stigma and mental health was a very powerful thing that I'd never been able to address really as an isolated scientist or clinician. But if that's what everybody is, everybody in the team is focusing on, can we represent this honestly, truthfully, in a way that will reach lots of people? Um, then you'll work together more cohesively. So I suppose my overall advice really is be humble, listen to other people, and recognize that you can bring something important, but that other
Yeah.
people bring important things too. Get used to working as a team as well. I mean, you don't
Yeah.
have to. A lot of people like to work in isolation, but I think as long as you're keeping an eye on what other people are saying and what expertise they have and what their perspectives are, the whole can then be greater than the sum of the parts.
Yeah, that's a really great perspective and excellent advice, especially I think with the nature that a lot of science is taking now, where a lot of problems are interdisciplinary. I personally have observed that it seems to be getting harder and harder for fields to try and solve these bigger issues that we seem to be facing in isolation, like you talked about. I know it's possible. I know it's been a trend in science for decades, but I personally like to see this more interdisciplinary approach that we're taking. And another question I have that's related to a bit of what you've talked about, but maybe getting a bit more specific is if there are other opportunities you see emerging in this connection between neuroscience and mental health for people who are starting to pursue these careers in neuroscience. We've talked a little bit again about your experience with neuroscience and psychosis in the Hellblade game, but are there other opportunities that you've seen popping up recently that get to combine those 2 fields a little bit?
Uh, well, that's a great question. I mean, I think I am seeing a lot more scientists who are recognizing the value of interacting with the arts and humanities, whether that's video games or cinema or whatever music as well. And I think those are all opportunities. I mean, what I think we need to be trying to do is think about mental distress, mental experience, and mental distress, and ask ourselves: is there a way of representing that? Maybe not directly, but through gameplay or through some media that brings other perspectives. Um, so for example, within the video game, where we're seeing people trying to, or quite successfully representing depression and traumatic experiences, and even things like dementia, cognitive decline with age. Um, So I think there's lots of interest out there in bringing separate disciplines together to exploit these opportunities. But there's so much that hasn't been explored, or there are so many different ways of exploring it. So that anybody who has something that really interests them about the brain or about mental experience, if they're thinking about what they can do, that look at all the different technologies, all the different ways of representing experience, and see what opportunities there might be.
What is one of the key skills to have when it comes to doing this line of work, or if someone who's interested in what you do, like what is like those skills that's just like it's definitely important to have, whether they're the soft skills or even the hard skills and everything.
Oof, great question. So I would say, it's very easy to point to bodies of knowledge and say you've got to be a great mathematician to do this, and you've got to be a great biologist to do that. I think those are things that you can develop through study and through experience. But I think they have to have at their core a curiosity and an openness, just a sense of, you know, being baffled about things in many ways. You know, a sense that there are some really interesting questions out there that other people haven't answered. And okay, I may be young and I may not have done, I don't have all the letters after my name or whatever, but I can think about this and I can think about new ways of addressing it. And maybe what that boils down to is that, as well as curiosity, is a sort of confidence in yourself, not not confidence that you know everything or that you're going to be the master of everything, but confidence that you're comfortable, as you say, in asking questions, in showing your ignorance about things, but in wanting to resolve that. And that's something I think a lot of young scientists find difficult because they come into science and they think, well, I really ought to know everything. If people find out I don't know this, then they're going to think I'm no good, or they're going to, they're going to, they're going to write me off. And, they even do that amongst themselves. So you find a small group of junior scientists talking, and sometimes you can see the competition amongst them about who knows what and who doesn't. And I think that's a shame, because it's the ones who ask the questions, who aren't afraid to show the things they don't know, that really make the progress. So I think curiosity and a confidence that you can ask questions, and it doesn't show that that you're ignorant or that you're no good. It shows that you're curious.
Yeah, and I think it sounds like there's a lot that you've learned throughout your career and throughout your path to where you've gotten now. And I think that that issue of sort of confidence and of feeling like you're in the right place, or you have that wiggle room to figure out if you're in the right place. I know that that can be uh, pretty difficult, like you said, for people starting out, for younger people who might not feel like they've got the room to make those mistakes, or to not feel smart, or to not feel like they're in the right place. But let's say we've got someone who's got that confidence and they've got that curiosity that you talked about, and they are interested in pursuing a career in neuroscience. Practically, where would they start? What advice would you give to them on getting into this field?
Well, the first thing I'd say is that there's a lot of doors into. Obviously, there's only one neuroscience, which is the science of brain processes and neural processes. But a lot of people are interested in something more fundamental like that, such as consciousness or memory or distress or psychiatric illness. And I don't think you need to be a neuroscientist to say important things about things like that. So, okay, if you're really fascinated by how the brain works, then trying to get on a course looking at neuroscience or biology is a great way to start, to learn the fundamentals. And of course, there's a lot of resources online that can teach you about the fundamentals of the brain. I mean, some of the YouTube sort of 5-minute videos giving you the basic principles are so high quality. And that's a great way to discover if it interests you. Um, but ask yourself, do I want to learn about how synapses form, or, what the neurotransmitters are, how they act? Or am I more interested in a different level of explanation? Am I more interested in, um, the psychology of memory, and what sorts of processes or experiences make up memory, and how that's affected by my surroundings? And that's a different thing, that's psychology. Um, or, you might be interested in the nature of how society influences mental distress. And that's much more about sociology and epidemiology. You may be interested in the mathematics of it. There's a big field now on trying to model how brain processes work at a mathematical or even a physics level. Um, you may be interested in the philosophy. All of those things feed into our understanding of the nature of consciousness and the brain. So the first thing I would say is that there's an awful lot of routes into the field. And if you have this, the first thing to ask yourself is, what really interests me? What am I curious about? What could drive me to want to learn techniques and facts and things? And that may not be a curiosity that's driving you towards neuroscience. It might drive you towards any of those other fields and many others. I think audio design is a great example of something that is clearly relevant to how we experience and perceive the world. It's not classically a neuroscience endeavor, but when when I talk to Cameron about his insights, I'm thinking, "Yeah, this is so relevant to neuroscience and to the neuroscience of psychiatric illness." So I'm sorry, I'm waffling a bit, Audrey, because it's a great question. But I think that the first thing is, think about what your interest in your question is, and then realize that there's a lot of doors into that, and choose the sorts of approaches that you think you would be happy in.
Yeah, I think that's gonna be great advice for our audience, and no worries about the waffling. I think it's really you bring a really, I think, interesting perspective, and, given how sort of long you've been in this field and how your career has evolved as a neuroscientist, I think it's really great for our audience to get that perspective, and to get, all the bits of advice that you've got to offer.
Yeah, and that's the other problem. What are the opportunities? It's so I was very fortunate. I didn't come from a rich family, but I was going to university at a time when in the UK university was free. You just had to get the grades, and you could get in, and they would even pay you. They'd give you a grant. And so I sometimes feel that I'm giving this advice that um, is not so relevant to people who don't have the opportunities that I had.
Is there something that you're often curious about that's outside your field or that's in your field and everything? Like, what goes through Paul's mind and everything?
I don't think about science all the time. In fact, I spend a lot of my time not thinking about science. And then I realize that actually what I am thinking about is related to science anyway. For example, I'm a very keen runner. Um, and I'm fascinated by the mental side of endurance sports. I think there's something really interesting um, about how some days you go out and you feel absolutely great, and you're looking at your watch and you're running faster than you have done before. And then the next day you go out and everything feels harder. You're breathing, your lungs are burning, and there's no difference. You're the same you've got the same levels of fitness. And I realized that so much of, endurance sports and probably lots of other things are about the attitude you're bringing to these experiences. And so I suppose one thing that goes through my mind quite a lot is how our minds interact with our body. We can't think, our mind isn't just some sort of puppet master that's telling the body what to do, but ignoring it otherwise. It's getting signals, it's getting hormonal signals and neural signals, it's getting all sorts of experiences um, that are plugging directly into how we experience the world. There are fat cells in your body that can actually secrete a hormone that changes how rewarding your brain finds food. There's just so much, you are an organism as a whole. And I suppose one of the things that really fascinates me is um, how do we bring the physical and the mental together? You know, a really holistic experience. And this gets back to the idea that there's so many ways into neuroscience. I think people doing physiotherapy probably have a huge amount of understanding about the nature of the mind through their clinical experience. Uh, Kinesiologists, all sorts of people working below the neck actually probably have a lot of insight into what's going on above the neck. So yeah, that's one of the things that goes through my mind as when I'm running, I can't think about anything but keeping going. But afterwards, and I'm thinking, how is all of this coming together? All of the oxygen and the hormones. how is that all coming into an experience that can be changed by our mental attitude, and at the same time can change our mental attitude?
Yeah, it sounds like there's a lot of big questions out there
Mm.
regarding the brain, and like you said, sort of the way it influences the way that we experience our lives. And to sort of maybe bring that into something we've talked about a little bit on and off throughout this discussion
Mhm.
is the way that the field has changed and the way science has changed, our approach to science, and more specifically, technologies have changed in ways that maybe allow us to approach questions in different ways or find answers that we just did not have the technology to find before. So, are there any ways that you've seen these technologies or this evolution of the field influence our ability to answer those questions, like things like maybe VR or AI or anything else that comes to mind for you?
Yeah, yeah, I think there's been an absolute revolution in information technology that perhaps we've been a bit slow to exploit it, but I think we're beginning to in neuroscience and medicine. Um, I think AI is a great example where very often what's hampered us in the past is that we as individual humans don't deal very well with complex data. We can deal with one or two variables, but when we've got multiple variables and they interact with each other in these complex, knotty ways, we really can't unpick it. Um, so bringing AI and machine learning into that is already having an effect. I was at a talk earlier today. This was an old PhD student of mine actually, and he studied medicine, but he's a great example actually. He studied medicine, and he became very disillusioned with it, and was much more interested in the maths or the math, as you say, and the computing. And so he sort of changed direction a bit and did a PhD with me in which he was using computing or early versions of AI to interpret brain scans, and particularly looking at people who had untreated epilepsy. So people who probably had something somewhere in their brain um, that was causing these epileptic seizures. But when a radiologist looked at the scan, they would say it's normal. It just looks, like there's nothing wrong at all. And he reasoned that if you could actually get AI onto this, that perhaps you could find a way to identify abnormalities that the naked eye couldn't see. And he's been very successful in doing that, and now has about 22 epilepsy centers using his program to really change clinical care for patients. Um, and I think that's a great example. It's an example of technology coming into the field. It's also an example of how you don't have to be doing medicine to contribute a great deal to medicine. You don't have to be doing psychiatry or neuroscience to contribute a great deal to the field.
You mentioned about consciousness. Um, what are the latest neuroscience theories about the nature of consciousness and everything? If you could describe it thoroughly by chance and stuff.
Oh, that is a very, very good question, but an extremely difficult one. So you know, consciousness theories have come and gone, and there's probably um, two or three major theories out there about how the brain can generate consciousness. There's one called the global workspace theory, which is this idea that the brain acts as a sort of um, arena in which processes are all coming together. And if those are properly integrated, then out of that conscious theory emerges, or consciousness emerges. Now, that's one of several that are quite similar. And to me, these are all just working ideas that are generating some interesting experiments. But for me, the interesting thing is that there's a lot more energy goes into the different people arguing with each other over whose theory is right than there is
Mm.
into the actual testing of the theories. There's an old saying in science that theories are like toothbrushes. Everybody's got one, and nobody wants to use anybody else's. And I think that's definitely true in theories of consciousness. Um, I think if any of the listeners want to find a field that is posing the biggest problems, the biggest amount of sort of argument and interesting debate, then neuroscience of consciousness is something to look into. For me, the thing that has really influenced my work and has really sort of felt right over both in terms of how it looks at clinical things and how it looks at scientific things and how it looks at life in general is something called predictive processing theory. And this is simply the idea that we have our brain and it's not in direct contact with reality. In fact, it's sitting right in the cavern of the skull, so it's got thick bone all around it. And all it knows about the world is the simple electrical signals that it's getting from its sense organs. So it actually has very little clear information about the reality around it, but it has to use that information in order to reconstruct that experience of reality in our consciousness. And for me, the most powerful explanation of that, of how it does that, is that it uses experience to predict what's out there. And it makes sense of these ambiguous and noisy and intensive signals based upon what it already knows. So it's continually using experience to guess and to construct reality that way. And at the same time, it's using the incoming signals to update its experience. So it's this lovely iterative process of predict, listen to the signals, update the predictions. And it's a complex theory, but it explains an awful lot of things. First of all, the fact that most of us are constructing reality, and that as a consequence, it's very easy for any of us to lose contact with that reality. It would just be a shift in balance that could cause that. So I guess predictive processing theory is my favorite theory.
So predictive processing is Paul's toothbrush that he'd be willing to use. Now we know.
Yeah, that's exactly right, Audrey. The nice thing about predictive processing is that there are other scientists who are prepared to use it. So,
What's next for Paul Fletcher? What do you have going on?
well, I think it's time to get back to the toothbrush for a while. Predictive processing theory is something that really excites me, and I'm planning some studies with a couple of PhD students around that and looking how predictive processing might be altered in people with psychosis. So I want to get back to some of my experimental work. I'm also doing more clinical work, seeing patients, which I always find very rewarding. Um, I'm continuing my close contact with ninja theory. So the Insight project that you referred to has sort of, it's been on the back burner a bit, but we do have some great stuff that they've created for us, some virtual reality experiences that we're starting to look at in terms of how they can help people manage anxiety. And I think that's something that I'm very keen to keep on. And as for what happens next with Senua and Hellblade, well, I can't say anything at the moment, but I think there's more to come.
Well, Paul, we really appreciate you taking the time to have this discussion with us today. It's been great getting to hear more about your work and just kind of about what's going on in neuroscience, and especially the advice and the perspective that you've been able to offer for our listeners out there who might be interested in pursuing a career in the field or exploring those interests that you mentioned that might not follow a traditional path, that might not have a traditional road laid out. I think that this hopefully gives them a great place to start from and some great insights on what it might be like along the way. So thanks. We really, really appreciate having you here. And it's been a really interesting discussion.
It's been a genuine pleasure talking to you about. Thanks, Cameron and Audrey. It's really, really enjoyable.